In Chapter 10, Part 1, Gases, we'll think about the characteristics of a gases and how we study this. So a gas spontaneously fills any container. So if we were to really think about what that means, if you have a container and you have a solid, you just get rocks or other blocks in the bottom. So this would be a solid. If you add a liquid into a container, you'll get some version of a liquid in there, but the liquid and the solid both only partially fill a container. If you were to put gas in a container, regardless of the quantity, whether it's, 1 atmosphere of gas, which is pressure, 3 liters of gas, whatever that is, it's going to fill the container. So typically we think about gases being in a container with a valve, and so the whole container is full of gas. So that's one characteristic. Mixtures of gases create homogeneous mixtures, meaning gases mix together. So if we mix a solid and a liquid, or you try to mix 2 solids, they don't necessarily always form a homogeneous mixture. So some gases are vapors from sublimation. So what is this? Water vapor, which we often call steam. And so that is basically just water in the gaseous form. So if you see vapor, that means the gas or the compound in a gaseous form. And they're highly compressible. So if we think about these 3 buckets of materials up here, if you have a solid and you try to make it smaller, so we're going to add a piston to the top, and we have our solid, we have our liquid, and we have our gas. And basically a piston is just a container with a lever that you can squish down. So the solids will compress, but only to a certain extent. Basically it shrinks to the size of the solid object. A liquid, you really can't. So we've all attempted to shove more water in a container when you try to seal it. So when you try to twist the screw cap or the cap to your water bottle onto a water bottle that's overfilled, water leaks out the side. With a gas, you can basically put pressure on this and it will get smaller and smaller to where the same amount of gas is compressed. So we see this in scuba tanks or other gas tanks. So these are some of the characteristics of gases. So pressure is really how we think or measure gas. Pressure tells us how compressed it is to some extent. So pressure is the force applied divided by the area over which the force is applied. Basically, it's P equals F over A. So the force divided by the area. Now, in other courses, we're going to calculate that a lot. We are going to use pressure as a tool, but this is where it comes from. Gases around us exert pressure on everything. That's called atmospheric pressure. We're really familiar with that when we think about how the atmospheric pressure will change, whether or not there is a weather front coming through. They'll talk about a drop in pressure or something else. So pressure units, so the SI units for pressure are the Pascal. And 1 Pascal equals 1 Newton per meter squared. So 1 PA equals 1 Newton per meter squared. And newtons are force over area. And so there are several other units that we can use to measure pressure, but the SI unit is Pascal. So how do you measure pressure? So gases tend to be really light, meaning it takes a lot of gas before we start to really feel like you could weigh that on a scale. And so we know they exist because you can remove gas via a vacuum. We know a gas exists, but we can't put it on the scale. So Torricelli thinks about how to measure atmospheric pressure. So the Torricelli barometer is rather simple. What we have is we have a dish And this dish contains mercury. So mercury is the only metal that is a solid. And so Torricelli takes a dish full of mercury, and then he inverts a glass tube that is sealed on one side. It's a little over 760 millimeters long. And so in this case, what he sees is that this will spontaneously fill with mercury, and that the size or the height of the mercury, so the height of mercury determines the atmospheric pressure. Because using displacement theory, as the atmospheric pressure pushes down on the mercury in the dish, it will cause it to either rise or lower based on whether on the atmospheric pressure. Basically, it can go up or down in this tube based on the atmospheric pressure. So we've heard of 760 millimeters of mercury. That, in fact, comes from this barometer, the measurement of what we see traditionally. And so he used this to determine that in the mountains, the pressure was different than it was at sea level. So there's pressure at all points, and it can change based on where you're located. So here are several units of pressure. So 760 millimeters of mercury is equal to 1.00 atmosphere, which is equal to 760.0 torricelli, or torr, which equals 101,325 Pascal, or it equals 1.01325 bar. These are all just different units. So you can think back to how we can convert units, and we'll do that frequently in this chapter using these different units of pressure.